Hello, Lena. Welcome to this channel. Let me appreciate you that you decided to stop by and watch this video. Obviously, I believe that you have a problem with mathematics, but I believe that if you have a problem with the topic that is going to be discussed today, after watching this video, all those problems will be sorted. As you have seen at the beginning of the video, that today we are doing the domain and the range of the function. I would advise you, Lena, that there is a video that we have done before this one, that you watch that video where we were dealing with the functions, specifically the definition of a function. So to understand more what we'll be doing today, you can watch that video, because this one is the extension of the function, because we are taking what is there in the definition of the function, the domain and the range, and we are looking at it in a very close way. So we are zooming in into the domain and the range of the function so that we may understand everything to do with that. I know for some of you would ask, why are we having a video for the domain? Because in the examinations, the domain and the range is more plus or minus 2 marks. But I believe that we're not doing mathematics only for the examinations, but we are doing mathematics because we enjoy mathematics. We want to know mathematics. I think the more we know, the better we can do. It's not always the matter of what marks do we get, how many marks do we get in the examination, but it's the matter of being a balanced mathematician, know your mathematics. So that is what we're going to do today. As I have said it earlier, that this topic for today is an extension of the definition of a function. I think we need to just recap on the things that we've done when we're defining a function the last time. So the first thing is the definition of a function. For instance, we say let A and B be sets of real numbers, then we can define the function as follows. A function is a rule or a correspondence which assigns each element in set A to a unique element in set B. A is called the domain and B the codomain or range of a function. So this is the definition of a function, learners. I believe that in the last video, we fully understood. We tried to look also at examples that demonstrate our understanding about the definition or about the function. But now in this video, we're gonna look closely in these two things, the domain and the range of the functions. That's what we're going to look at. So what is this domain? Now, as it has been also discussed in the previous video, the domain of a function is a set of all possible values, all possible or permissible values of x. That means that x is in A, according to the definition, for which the function is defined. Meaning, learners, if you are asked of a domain, you're looking at the x-axis, the horizontal line. We're looking for those x values for which our function is defined. And then we can go for the range. What is the definition for the range? It goes as follows. The range of a function is the set of all the y values. That means the y in B now, belonging to the function. We are looking specifically for those values that belongs to the function when we speak of the range. Unlike when we speak of the domain are all values of x for which the function is defined. So you must make sure, learners, that you really study this definition, you really understand what is being said. You see, the problem most of the time that makes mathematics to be difficult for most learners, for most people, is because they think that they can understand mathematics by only working on examples or exercises. Learners, if you want to know mathematics, you have to take your time, invest on the concept. Make sure that you fully understand the definitions, you fully understand the concept even before you can start doing the exercises, because the exercises are there to test you how much do you understand the concepts, not the other way around. You cannot understand the concept by working the examples, but you can understand the examples or the exercises by fully understanding the concept. So today we're gonna just look at different examples that will expose us to show whether we understand or how to tackle the questions pertaining to the domain and the range. So let's get started. Let's look at those examples. They are very exciting. We have got 10, I've prepared 10 examples for you. I believe that after you have gone through all those 10 examples, no question in the exam will defeat you, or you will not able to answer pertaining to the domain and the range of the function. Let's get started. Let's look at our first example. What are we asked to find here? What are we asked to do? Determine the domain and the range of each of the following functions. So we are told the following will be functions. So we'll have to determine the domain and the range. So immediately you see the domain in the question paper or the range, you must recite the definition, what the domain is and what the range is. If you keep it like that, then there is nothing to do with that you have to worry about, because you know exactly what to do and how to answer these questions. So the first function that we are given here, we're given this function there, f at x of y. So if we look at this, this is the function given as coordinates. You can see there. Now what we have to do here is to find first the domain and then determine the range. If we look at this function, the x values, obviously, if you are given a coordinate, the first coordinate is an x and the second one is a y. So for this function, we're having -2, -1, 0, 1, 2, 3. So all those elements will be constituting of the domain for this function. And when we are looking for the range, it would be the y coordinates in these coordinates. So it's gonna be 5, is 2, is 1, is 2, is 5, and 10. If you look at it, learners, there are some repetition in here. We have a 5 there, and also we're having a 5, which already supposed to be telling you what kind of a function is this, because remember, we have defined two functions to be two, either one-to-one function or many-to-one function. So now if we define what would be the domain for this function, here is our solution, as we already identify the elements which constitute the domain for this function. So the domain of f is gonna be -2, -1. Remember, you have to be careful on how you write your bracketing. Just go there, so that we can have that discussion on the different brackets that you have to use. So the meaning of brackets in mathematics, we've got 3 sets of brackets. That's the first one. I think you are most familiar with that one. And then how do we call that bracket? We call it parenthesis. Sometimes we call it round brackets or curly brackets. It doesn't really matter which way you're calling it, as long as you understand or you know at what instances you have to use it. The second one is this one. I believe also you are familiar with. How do we call it? We call it square brackets. These ones, you are using them when you are including the endpoints. And this one, you are using them when you are excluding the endpoint in your interval. And then the last one is this one, and is called the braces. And the braces, we don't use them in interval. We're using them to denote sets. If you are dealing with sets, then these are the kind of brackets that you are expected to use. So make sure, learners, that you understand these brackets, because they make a difference between getting all the marks when you have to write down the interval or when you have to write down the sets. The wrong use of any of these, you may lose marks, or if not, losing all the marks. So it is very important that you study these brackets and you understand the differences and where they are supposed to be used correctly. Let us now going back to where we're supposed to be doing. So we've already done the domain of this function. Is there in the screen, as you can see it. Now what is next for us is to determine the range. So remember, for the range are all y values that belongs to the function. So we can see there we're having our y values. That's a 5, that's a 2, that's a 1, that's a 2, that's a 5, that's a 10. But if you look at this, you can already identify that there are some repetitions in the range. You have got 5 there, and we have got 5 there. We have got -2 being mapped to 5, and we have got 2 mapped to 5. We have got -1 mapped to 2, and also we have got 1 mapped to 2. So you are supposed to already identify what type of relation is this or function is this, one-to-one or many-to-one. Of course, this one is a many-to-one. We have got many x values mapped to one y value. So it is not a problem. But now, when we are writing our domain, you can see there we don't have 2 2s and 2 5s. We're having 1, 2, 5, and 10. So when you are writing a set, you don't repeat. You don't put those repetitions in there. To write 1, it's enough. So the range of this function will constitute only these elements, which is 1, 2, 5, and 10. That would be the range for this function. Let's look at the second example. It's still the same question. We have to determine the domain and the range for this function. So which function is it? Let's look at it, learners. Yes, it's something that most of you are familiar with. It's a table. This one is tabulating our function in terms of x and y. Remember, learners, once you have x and y, sometimes there are terms that are being used in mathematics that you need to understand. Sometimes this variable, we call this one an independent variable, and y is always the dependent variable. If your function is written in a table form, most of the time the first one will be your independent and the second one will be your dependent variable. This one, there's not much that we can do because you can see the domain has been listed easily for you to understand it. So the x is your domain and your y is your range. We can just write the solutions down quickly here without wasting any time. So that will be our domain for this function, and then that will be our range. Forgive me for the mistake there. There should have been an R there. So you can see the domain for this function is all those values of x there. They are listed in ascending order. Same applies with the range. They are listed there in that ascending order. So that would be it for this example. Let's look at the next. Now let's look at example 3 and see how do we go along with this question of determining the domain and the range of the function. Example 3 is presenting us with this function here. We can see obviously that this is a function because you can see all the elements in the range have been mapped, because in our definition we said every input point must be mapped. So everything here has been assigned, and then this is the function. Now, if we have to determine the domain in here, also is easy because we can easily see the elements of the domain and the elements of the range. But if you're looking at this set, this is not our range. This is our codomain because we're having 30 there, which hasn't been assigned to anything in the domain. So if we are looking specifically on the range for this function, we only take 10, 20, and 40. That would be our range because those are the elements of the y that belongs to the function. So let's write the solutions, learners. So the solutions, you can write them in the following fashion. So you can see the domain of f will comprise or constitute these elements. So it's 1, is 2, 3, 4, and 5, written nicely. And then again, if we are looking for our domain, our range, then our range only constitute of 10, 20, and 40, but 30 is not included. That would how you would write the domain and the range for this specific or particular question or function. So example 4, let's look at example 4. What is example 4 is entailing or want us to do? Let's see, you are given this function now. Determine the range of f of x equals to minus 2x squared plus 5. If the domain is, that is the domain that we are given. So this question now is a little bit different from the previous one because you're given the domain, you're given the formula for the function, but you have to determine the range. So this one, we have to do some calculations, unfortunately. We have to do some calculation to determine the value or the domain, the range for this function. Let's get started. If we are now looking at this and we have to determine the elements of the range, given the elements of the domain of this function. Here is the list of all the elements of the domain. Then we have to find the element of the range. So we will do this by substituting each of these elements for x in our function. We started with -5. Wherever there's an x in our function, we substitute that, then that will give us the corresponding y value when x is equals to -5. So let's get started. So that means the first thing that we're going to do, we have to determine f at -5. So what are we gonna do? Wherever there's x in our function, in our formula, we substitute -5. So we say -5 and we square that plus 5. And then doing a quick calculations, I think we can do this by inspection. -5 squared is 25. And then times that by -2 is -50. -50 plus 5, learners, obviously, is minus or negative 45. So we have the first one. Now the second one, we're going to substitute -3 into f. So we do f at -3. What is it going to give us? It's going to give us -2. In the place of x, we substitute -3. We square that and say plus 5. And then we do the calculations. -3 squared, it should give us 9. And 9 times -2 is going to be -18, of course. -18 plus 5, it would give us -13. That would be the corresponding y element there. Then to carrying on with that, and then we're having 0, meaning we have to do f at 0 is going to be equals to -2 into 0 squared plus 5. And then obviously anything you multiply by 0 is going to give us 0. So the answer there will be 5. The next number in our domain is 4. Then that will take us to do f at 4. So again, where there's an x, we substitute it with 4. So we're doing the calculations there. 4 squared is 16. 16 times -2, obviously, is going to be -32. -32 plus 5 is going to give us -27, learners. Then we have the next number in our list is 7. So let's do f at 7. What does this take us to? We have to substitute 7 in the place of x, and then we simplify. Then 7 squared, obviously, is 49. 49 times 2, -2, it should be -98. -98 plus 5, that would give us -93. That would be the y value there corresponding to 7. And lastly, but not least, we're having a t there. I know most of the time when learners are finding something which looks strange or something that is not like the others, they start panicking. You don't need to panic. You just have to stick to what you know. We have to, as we are substituting all these other numbers, and t also, we have to substitute into the formula and find the corresponding y value. So that means there we're going to do f at t. Our f at t there is going to be -2 in the place of x. We replace it with t and we square that plus 5. And then if we are simplifying this formula, it's going to be -2 t squared plus 5, which is our corresponding y value when x is equals to t. So we're now having all the elements of our range. We can write it down nicely. So just wait a minute and then I will show you the nice solutions as I have prepared them. So now the solutions for this example, remember learners, the question was determine the range, only the range, because we are given the domain here. Determine the range of f of x equals to -2x squared plus 5 if the domain is given by this set. So on our solution, as we have done already the calculations, that's how you would write down your range for this function. So your range will be your -45, -13, 5, -27, -93, and then when we substituted t, we got that the corresponding y value is -2t squared plus 5. So that would be the range for this function. The next example here, determine the domain of g of x equals to x minus 3 if the range is y equals. So these two questions are very related, but they are different. Remember, on this one, we were given the domain. We have to find the range. But this one, we are given the range, and we have to determine the domain. We're working backwards. It's a reverse. So that means even in the manner we are doing it, it's not going to be the same as this one. In the first one, we're substituting this where there's an x. But for this one, we're going to substitute these elements where there is y. So we're going to change g of x to y, and then we substitute each of these and to find the corresponding x value. So let's get started. Let's do the domain for this one if the range has been given to be this. So now, learners, we are having our g of x there, and we are having our range of this function been written there. Here are the elements of the range, and then we have to find the x values or the elements of the domain. So we will say, instead of now having g of x, we'll say y equals to x minus 3. So for each of these, we will substitute there for y and calculate or solve for x and find x. So the first one is minus 3. If we replace y with minus 3 there, we'll have minus 3 equals to x minus 3. And if we take minus 3 to this side, is going to be positive. Do we agree? Then we'll be having x equals to 0. That would be the first one. Secondly, again, if we're using 2, we'll have 2 equals to x minus 3. And again, taking minus 3 to this side is going to be positive, and then we'll be having x equals to 5. And the next one in our list is 17. We substitute 17 equals to x minus 3. We take minus 3 over, is going to be 17 plus 3, which will be 20. Now we'll be having x equals to 20. So the next one, the last but not the least, is we having t minus 3. You can see there in the function, our function is x minus 3. So what happened to get t minus 3? We simply substituted t there. So you can simply say there, our x is going to be t. Or you can do the substitution, the normal substitution. In the place of y, you replace with t minus 3 is equals to x minus 3. Again, if you're taking this minus 3 over, it's going to be positive, and then minus 3 plus 3 will cancel out, and then you'll be left with x equals to t. I mean, this one you could have done it without substitution by just using your mental faculties to answer this question. Let us again look at our already prepared solutions, and obviously the manner in which you are expected to answer or to write your final answer after the calculations, of course. So the solution for the range of this function, the solution for the domain for this function is as follows. Domain for f, or for g this time, not f, the domain for g will be 0, as we have calculated, 5, 20, and t. Those are the elements of the domain, given that the element of the range in there were the minus 3 to 17 and t minus 3. Okay, now let's look at now example number 5 and see what challenges that it will present us with. So again, we still have to determine the domain and the range. So if you look at number 5 now, is the graph. And it's a graph of a straight line. So we have to determine the domain and the range. Remember, the domain are all x values for which the function is defined, and the range are all y values for which the function is defined. Now, if we have to answer the question of the domain for this function, that means we're looking at the x values or at the x-axis, and we ask ourselves, is there anywhere in the x-axis or in this function where this function is not defined? I cannot see anywhere because each x there is mapped to something in the function. So this function is defined for all of x. So hence we can write the domain if we're gonna use the set builder notation in this way. X such that x is an element of real numbers. Some other people or learners do not write x such that you just write x an element of real numbers. You are also correct if you write it in that way. And again, if you're looking at the y-axis, looking now at the range, if you look at this function, you can see it is there also in the negative because those arrows means the continuity. This function continues all the way. So in the below the x-axis, you can find there in the negative y-axis and also in the positive x-axis. So also the range, it takes all of R. Hence, we will write the range for this particular function as y such that y is an element of real numbers. In the similar way, let's look at example 6 and see what we're going to be asked about the domain and the range of the function. Example 6, again, we're given a graph. I think this graph is more or less the same as the first one. The only difference is that this one is lying to the left, but I think you are spotting something like the way I am doing. There's something strange about this graph. Learners, can you see what I'm seeing that is different from the first graph? Let me give you a minute to see what I'm seeing, if you'll be able to see. Yes, of course. If you look there, it's not like there's a hole in the paper there. It's just the graph is undefined there. There's a jump, there's a hole there. That's open circle there. That means the graph there is not defined. So if we are looking now at the domain for this function, we have to say, we can see it's defined everywhere else like the previous example, only at -2 where you cannot find the value of y for this function. So this function is not defined at -2. So we can say now the domain for this function is everything in R in the x-axis except at -2. But how do we write it? We write it in the following way. We say x is an element of real numbers such that x is not equals to -2. So that will be the domain for this function. If you could be given something like this and then you are asked to find the domain for this function, this is how you will be expected to write. Same applies when you have to determine the range. You can see there we don't have the function value of y for this function there at 2. So it is everything in the y-axis except at 2. So this is how we will be expected to write the range for this function. Again, we will be saying y is an element of real numbers such that y is not equals to 2. So that would be it, learners, for this function for the range and for the domain. Remember, there are other ways of writing the domain and the range. Sometimes you can write it using the interval notation instead of using the set builder notation, which is this one. I believe that in other videos that we're gonna do, I'm gonna show you the difference between the different ways of writing your intervals. So in this example 7, we are given this function now. This is kind of a function which is easy to draw, but trust me, most learners are finding this function being a challenge because they are always kind of used to the slanted function, either to the right or to the left. But now when they are presented with a horizontal line like this one, they just freak out. This is just cutting the y-axis at 5. So again, the question is still the same. We have to determine the domain and the range for this function. And if we look at the x-axis, finding the domain, you can see for every x value, there is something in the function. So this function is defined for all x values. But now if we look at the range, this function, you cannot find it anywhere below the x-axis. So it is not defined there. And also above the x-axis in the positive y-axis is only defined, all these x values are mapped to 1 point. It's a many-to-one function. So they are mapped to 5. So there's only one element of the range for this function. So in order to get all the marks, this is how you will be expected to write the domain and the range for this kind of a function. Then because we have already said that it is defined for all of x, we say x such that x is an element of real numbers. And for the range, we say is y such that y is equals to a set with only one element, which is 5. And the next example, example 8, again is a graph. But now it's a straight line graph, but it's presenting us with a different kind of way of looking at it. If you look at it now, this straight line is not continuing indefinitely to minus infinity or to positive infinity. We can say maybe we have a second. It has got a starting and an ending point. Another thing that we need to note on this graph, the end points there, this one we're having an open circle, and on this side you're having a shaded circle. So you need to be careful because these things are not there by a mistake. There is something that they are telling you. This one means that you don't include the end points. That means that point there, -4 and 2, is not part of this function. And also there, this one, since it's shaded, that means you include the endpoint. That means -7 is part of this point and -9 is part of this point. Now, but the question that we have been asked is to find the domain and the range for this function. Now, if we look at the domain, we will have to find the corresponding x value up to this point. If you now draw that line vertically to the x-axis, we can see that the x value there is this one, which is -4. Again, we will need the x value that correspond to that, which is 7 in this particular case. So again, if we draw that line to the perpendicular to the x-axis, we're having 7 there. So the domain for this particular function now is not everything in x, in R. So this one is between -4 and 7. And remember, learners, -4 is not part of the domain because we have got an open hole there. It takes anything above -4 up to 7, and there we're having a shaded circle. That means 7 is part of the domain for this function. So the way we're going to write it, we write it in as follows: x, an element of real numbers such that x is greater than -4 or x is less than or equals to 7. You can also write it in an interval notation, but for not confusing you at this stage, let's just stick to this set builder notation. Now let's look at the range of this function. For the range, again, we will need this point here, which correspond to this point. The y coordinate there is 2. Then if we draw a horizontal line there to the y-axis, perpendicular to the y-axis, we can see that that point there will be 2. Again, if we draw another horizontal line to the y-axis there, we have the corresponding y coordinate there, which is -9. We can see now that the range for these functions is between -9 and 2. And hence we can write the range for this function as follows: y is an element of real numbers such that y is greater than -9 and y is less than 2. And the emphasis there, you must also remember, we said there, because this point has been included, we use less than or equals to, because -9 is part of the interval. But look at 2, we use strictly less than 2 because there we're having an open hole. That means 2 is not part of the range of this function. Same thing that we've done for the domain. We said x strictly greater than -4 because -4 is not part of the domain, it's not there in the function. So we take anything above -4, but 7 is included. That's why we said there less than or equals to 7. So you must be careful for those little details, learners, to ensure that you get all the marks. Let's look at the next example. Now, example 9 again is a graph. I think some of you are familiar with this graph. Obviously, you can tell that this is the hyperbola. But we're not interested now as to exactly discuss what the function is, because it is not the question that we have been asked today. Today we are looking only at the domain and the range of the function. So if we analyze this graph here, we can see that this graph from minus infinity, it is defined, but the problem is here. We're having this line here. We call this line an asymptote, a vertical asymptote. We know that an asymptote is that line that the graph keeps on getting closer and closer, but not necessarily touching it. You see there, the graph is getting closer to this line, but it's not intersecting the line. And even there, you can see the graph is getting closer. So this is an asymptote. We have got a vertical asymptote, and also we have got a horizontal asymptote. So we know that in the hyperbolic function. So if now we have to define the domain for this function, it will be all of x, because it is defined everywhere else except at 2. So the domain for this function would be x, an element of real numbers, such that x is not equals to 2. And now if we're looking at the range, so you can see there it is defined. You can find the value of this function everywhere else except at this point here where you're having your horizontal asymptote. That means it will be all of R except 3. So the way of writing this, we will say y an element of real numbers such that y is not equals to 3. So we're having our last example. You must brace yourself, because it's going to be something very interesting now. We're going to take things to the higher level. So you must brace yourself before we do the last example number 10. Okay, let's look at this example. I'm very excited. It's a very exciting example. Here is example number 10. You're given this graph. Whoa. I think all of you are some kind of thinking, what kind of graph is this? But it don't matter. This is what we call a piecewise function. For those learners who are doing AP Maths, I think they are familiar with this graph. Some of you, unfortunately, you will only see it in university, but don't worry. You will get to know this. It's not difficult. It's just a mixture of functions, but being drawn in certain intervals. So we call this kind of a function a piecewise function. So, but our question now is not to analyze the function or the graph, is just to analyze or to determine the domain and the range. But we have been, if it has even been restricted here, minimized to just find the domain. So we'll just be finding the domain for this function, and that would be it. Let's just focus on that and get that done and relax. So let's look at it, learners. Let's look at the domain for this function. If we look at this function closely, we start, it is always advisable to start reading it from the left and to the right. If you look at it from the left to the right, you can find the function value everywhere from minus infinity. Then the problem starts at minus 3. We're having a vertical asymptote. That means this graph, this function is undefined at minus 3. The graph is getting closer and closer to this line, but not necessarily touching this line. So again, if we move from minus 3, you can find the function value for this function all the way up to this point there. Can you see? And this point there is minus 1, corresponding to this x value there, the x coordinate. So it's minus 1. We can find the value for the function is defined there. But there is this point, there is this part now. The function is undefined there. There's nothing, there's no graph in this interval, either above the x-axis or below the x-axis. You must take that into consideration. And if we move along from 0 now up to this point there, which is x equals to 2, the graph is defined. And now remember, learners, we still again having this open and close. You must remember those when you are writing. You must be careful there when you are writing this part of the domain of this function. And there is this part where the function again is jumping. You don't have anything there. You must remember to exclude that part. And moving from there, we have got this part. You can see there we're having 3 and we're having 4 there. Then we have how many parts for our domain for this function? We have got 1, remember, 2, we have got 3, and we have got 4. We have got these 4 parts for the domain of this function. So let's write it down, learners, nicely. So this is how you would be expected to write down the domain for this function. As you can see there, it is having all those 4 parts. We're having this part 1, 2, 3, 4. But let's just analyze quickly as to how it has been written down. We say x is an element of real numbers such that, first of all, we looked at this part. We said the domain, you can find the function value of this function everywhere in this interval from -infinity to -3. Hence, we say x strictly less than -3 because -3 is not bad. From -3 onwards, you can find the function value for this function. And we said, again, we're having this interval here above -3 up to 1, and -1 is included because we're having a shaded circle there. So we say x is strictly greater than -3, but x is less than or equals to -1. So we're done with this part. Also, another one that we have the function value is there, remember, from 0 up to 2. So this is what we write there. Remember, 0 is included because we're having a shaded circle there. We say x is greater than or equals to 0, or x is strictly less than 2 because there we're having an open hole. So there, 2 is not part of the interval. That's why we're using that open hole there. And the last interval is that one between 3 and 4. Remember, 3 is a shaded circle. That means 3 is included. And 4, at 4, we have got an open hole, meaning 4 is not included. That's why we have to write it in this form. X is greater than or equals to 3, and x is less than, is strictly less than 4. So that's how we write it, Lena. As I have mentioned to you earlier, that there are many different ways of writing an interval. We have got a set builder notation. We have got an interval notation. We have got a number line, which you can choose from. So now I am going to just, with the solutions for the last example, I am going to show you how to write those solutions now in an interval notation. So let's get the way we could write this in an interval notation as it is now in a set builder notation. We can write it as follows. We say x is an element. And remember, learners, I said you need to be careful in the manner you are writing your brackets. And I said to you, we have got 3 types of brackets. We have parentheses, which are the round brackets, and we have got square brackets, which are looking like this, and then we have got braces, which are the ones that we were dealing with in the examples. Now, if we are writing this, we have to write this interval now, this domain in an interval notation. Then we'll be using these 2 brackets. The round brackets or curly brackets means that you are excluding them, or you use them when the end point is not part of the interval. And if you are using this, you're using this when the end point is part or is included in the interval. So in this one now we can see the x less than -3. So that means this interval, we're taking it from -infinity, because you cannot include -infinity. So you use the curly brackets and -3. And -3 is not included, is not part of the interval. So that would be it for this part. Now, instead of using or in an interval notation, we use union. Union to this. This is an interval between -3 and -1. But -3, remember then, x is strictly greater than -3. So -3 is not part of the interval. So we will use the curly brackets. We say -3 and -1, but -1 is included because this one is less than or equals to, so we will use the square bracket, and we say union. The next interval is between 0 and 2. 0 is included, obviously we use the square brackets, and we say 0 and 2, and 2 is excluded, then we use the round or the curly brackets, and again we say union to the last interval, and the end point here is included, the last end point is excluded, so we use the square brackets and say 3 and 4, but 4 is not included, then we use the round bracket or the curly brackets. So that would be it. If you want to write the same information now, not in a set builder notation, but in an interval notation. The essence of this example, I was just throwing you to the deep end so that whatever that you might be asked, it might be given, that you may not panic. You just look at the question, you just answer what you're supposed to answer, irregardless of what it is there that you are asked to find. Because most of the time, learners like to be asked things that they are familiar with. It doesn't have to be familiar, learners. Just stick to what you know. If you know what the domain is, just do the domain or determine the domain, regardless of what is given to you. With that having been said, with that having been done, I thank you for the time that you spent to watch this video. I believe that you're also going to follow other videos that I am going to do. Thank you. Let me once more thank you for stopping by and visit my channel. I believe that whatever you wanted in terms of the domain and the range of the function, all your questions have been answered. If you want to follow me, you need to subscribe, and also you can follow me on the Facebook page, because most of the information that I will be doing and the videos that I'll be uploading, I will be giving that information on my Facebook page called Mathematics Champions. Just search there, the Mathematics Champion, and like the page. Then I will invite you. Everything that I'm going to do, I will post it in there. Just keep safe, keep on practicing mathematics, and then it will be easier for you in the examination. So our next video that we're going to do, we will be doing logarithms or logs. So we're going to just look at the logs so that to better prepare ourselves to do the inverse of the function. Stay safe up until we see each other again. Thank you.